Alright, so the idea of the factorial is this. If you have 10 little kids to line up at the door for recess, the first place in line, there's 10 choices for that spot. The next choice in line, well, there's only 9 spots left for, you already used one of them. And then 8 and 7 and 6 and 5 and 4 and 3 and 2 and 1. And you need a first place guy and a second place guy and a third place. And whenever we hear the word and, we think multiply. So there are this many ways that you can line the kids up at the door. Now that idea is what's called 10 factorial. Okay? Now, it's important because little kids care about what order they go in. So, Johnny, I hate Johnny. Joe and Beth and Susan. Susan, there you go, is different than Beth, Susan, and Joe. To them, it really matters what order they're in. So, because order matters, and it does oftentimes, we have the case of what's called, in this case, 10 factorial. If there's 5 kids, of course, it'd be 5 factorial. Now, your computer, calculator, Excel will do this for you. So will Google Sheets, same exact process. What you're going to want to do is you're going to go equals, well, hallelujah, fact, about time that guy hit one out. At fact 10, let's say. That's 10 factorial. That's how many different ways you could pull that off. Okay? And again, that's because we're using everybody and order matters. Now you're like, well, wait a minute. What if there was only 3 awards in a race, but 7 guys are running? Okay, well, does order matter? Sure it does. So you'd have 7 choices for the first place guy, and 6 and 5 like this. This is similar to factorial, but it's a little bit different. It's what's called a permutation. Now, what we have here is we have 7 things, and we're taking them 3 at a time. And so most books will write it like this: NPR. It's a permutation of n things r at a time. Again, permutation, order matters. So the formula is actually this. It's n factorial over n minus r factorial. And back in the day, this is what a guy had to do. He had to do this problem. You do 7 times 6 times 5 times 4 times 3 times 2 times 1 on the top. 7 minus 3 is 4 factorial. Oh, there's not a... So 4 factorial is this guy. They would cancel, and there's your answer. Okay. Now again, Excel can pull that off too. What you're going to want to do is go equals permut. I will say this is that some people, for instance, there's 840 ways those people can finish the race in the orders of 1, 2, and 3. That doesn't mean they're all equally likely. Okay, and the race this week, in the NASCAR race, there's going to be 43 or so drivers. And if you want to talk about the first 3 places, well, it's 43 times 42 times 41. Well, there's some drivers right now that aren't going to win. So Danica Patrick is not going to win. She's not won a race. She's not looked like she's even close to winning a race this year. Probably not going to happen. Could happen, not likely. Okay, Jeffrey Earnhardt, another guy that, driving a poor car, he's not a very good racer, whatever. What's that? Corey LaJoy guy or whatever, right? There are 3 guys that are 3 people that either aren't very good, kind of new to the sport, and or aren't driving a very good car. It's possible that they could finish in the first place or the second place or the third place. It's not very likely. It's way more likely that a Kyle Busch or somebody that you've heard of, like Jay or Jimmy Johnson or somebody is going to win because they're good and they have good driver, they have good cars and what have you. So again, there's this many ways to make that happen, But the question is, are they all equally likely? And the answer is they aren't all equally likely. It's just that they are all possibilities. So again, it's equals permute parentheses 43 comma 3. There's that many different ways that people could finish the race this weekend. Again, though, not all equally likely. Now, combinations is the other way it could happen. So if I need 3 people to come help me, I don't care if they're blondes or brunettes or redheads. I don't care if they're male or female. I don't care what's going on. I just need people. Hey, come here and help me. You're going to help me carry a couch or something. So there's no differentiation in terms of who's helping who with what. I just need people. Well, if there were 10 people to choose from, and I need 3 people, I need to choose 3 people. But the difference is order doesn't matter, you see. And so permutation would be 10 factorial over 10 minus 3 factorial. Or in other words, it would be 10 choices for the first one, and then 9, and then 8. But the problem with that is that Bob, Joe, Sue is the same as Sue, Joe, Bob. They're all the same because it doesn't matter what order they're in. Okay, I just need people. And it turns out that if you look at this, there are 6 different ways those guys can be organized. 6 different ways that you can take 3 people and organize them in different directions. And so it turns out that when I do this problem, we're going to see in a few minutes, I need to divide by 6 because I'm having some repeats here. Okay? So when we're done, there's going to be 120 ways to do that in a minute. We're going to see that. And so the idea is a combination says, hey, order does not matter. And why doesn't it matter? Well, I just need people. If you reach into your laundry basket and grab some white socks and some black socks, can you tell one white sock from another white sock? No. Can you tell one red marble from another red marble? No. They're red marbles, and you don't know the difference. So a combination is similar to a permutation, and we write it like this: n choose r, n c r. And the formula is n factorial over n minus r factorial times r factorial. Okay, this all being in the denominator. Now, of course, the computer can do it for us, and I want you to use the calculator computer to do it. So it's equals combin, and then let's say it's 10 comma 3. That's what I think I asked about. There's 120 ways to pull that guy off. Okay. Now, in general, you're like, what do we use these ones for? Well, we use these for frequently. God dang it. We use them for frequently for problems kind of like this. These are all the same size marble. There's 8, and then there's 10, 11, 12, 13, 14 marbles in there. Reach in blindfolded. Okay? You can't tell them apart. They're all the same size. They all feel the same. I want you to select 5 marbles. And reach out and grab a handful. Just reach in, grab a handful of 5, bring them out. Okay? So when I do that, my denominator is going to be 14, choose 5. We don't care what order they come out. We just want them to come out. Right? So that will be my denominator. That's how many different ways you can select 5 marbles out of 14. So on the computer here, we just give it one of these jobs. I'm just going to edit this one. Boom. 2002. 2002 is my denominator. Well, now we're going to ask a question. What's the probability that I get 2 black, 2 stripe, 1 star? Well, I don't know. There are 6 blacks, and I am choosing 2 of them. And, so multiply, There are 4 stripes, and I'm choosing 2 of them. And there are 4 stars, and I'm choosing 1 of them. Okay? Now, I do this individually on a calculator. Here's some things to think about as we do this. Anything choose 0 is 1. Anything choose all of them is 1. Anything choose 1 is n. And if you have n choose x, that is always equal to n choose n minus x. For instance, 10 choose 7 is equal to 10 choose 3. It always works out that way. Okay? So, when you have this guy here, 4 choose 1, well, that's equal to 4. So up here, you look like an idiot doing this one on your calculator. That's just 4. I happen to know this one is 6 off the top of my head, but if I didn't, I'd ask Betsy. And then I'm going to do the other one on the calculator because, well, I don't know what it is. It would just be equals combin 15. Actually, I would have guessed that if I'd have thought about it for a minute. Come on, open up. So, what's 15? And so it's 15 times 4 is 60 times 6 is 360 out of 2002. That would be my probability. And it's pretty straightforward. I would like to mention that 6 plus 4 plus 4 adds up to 14. That is, the numbers on the left on top add up to the numbers on the left on the bottom. Numbers on the right on top add up to the numbers on the right on the bottom. That's something that I always do just to make sure I didn't screw something up. It's a good way to check yourself. But that's kind of the idea there. You could do it something like this. You know, there's 10 people in the room. There's 6 women, 4 men. Whatever. You could ask this question: how many ways? How many different ways, or how many different 3-person committees? If you hear committees, that's classic. It's a combination. Can you make? I don't know. I know this, though. I would say that there are 10 people, right? And I'm choosing 3 of them. 10 choose 3. That would be my answer to that question. I feel like I already did that one, but we'll do it again. So equals combin 10, 3. Booyah, 120. Now, there's 120 ways to do that. Okay? Now, a person could phrase this a couple of ways. You could ask them, what's the probability that you get two men and a woman? 2 men and 1 woman. There we go. So we know the denominator is 120 because there are 120 ways to select 3 people out of 10. But I need to have 4 men, so I need 2 men. So 4 choose 2, and 1 woman. 6 choose 1. 4 choose 2 I know again is 6, but if I didn't, I'd go look it up. 6 choose 1 is 6 over 120. The answer would be 36 out of 120. Anyway, hope that helps you.